Hello friends, my name is Ankita Suresh Maing. I am studying in class BSc first year from college Adarsh Mahila Education Society in Hingoli. I have representing a Rolle's Theorem. There have a three condition. If a function f is first continuous if a closed interval a comma b, second derivable in the open interval a comma b, third f of a equals to f of b, then there exists at least one value c epsilon open interval a comma b such that f dash of c equals to 0. Proof: by virtue of the continuity of the function in the closed interval a comma b, it has a greatest value capital M and a least value small m in the interval, so that there are two numbers c and d, such that f of c equals to capital M, f of d equals to small m. Now either capital M equals to small m, equation 1, or capital M not equals to small m, equation 2. When the greatest value coincide with the least value, as in case first, the function reduces to a constant so that the derivative is equals to 0 for every value of x, and therefore the theorem is true in this case. When capital M and small m are unequal, as in case second, at least one of them must be different from the equal value f of a, f of b. Let capital M equals to f of c be different from them. The number c, being different from a and b, lies within the closed interval a comma b, and as such belongs to the open interval a comma b, is in particular derivable at c, so that limit of f of c plus h minus f of c upon h when h approaches 0 exists as and is the same when h approaches 0 through positive value. Also, f of c is the greatest value of the function. We have f of c plus h less than equals to f of c whatever positive or negative value h has. Thus, f of c plus h minus f of c upon h less than equals to 0 for h greater than 0, equation 3rd. F of c plus h minus f of c greater than equals to 0 upon h for h less than 0, equation number 4. Let h approaches 0 through positive value from third, we get f dash of c less than equals to 0, equation number 5. Let h approaches 0 through negative value from 4, we get f dash of c greater than equals to 0, equation number 6. The relation 5 and 6 will both be true if and only if f dash of c equals to 0. The same conclusion would be similarly reached if it is the least value which from f of a and f of b. Hence, the theorem is true. Thank you.